Hey there, and welcome. Sometimes the solution to a huge problem can come from the most unexpected place. Today we're going to talk about something really cool, how scientists are taking one of our biggest environmental headaches, plastic trash, and turning it into a high-tech tool for a better future.
So, it all really starts with this one question. Can a simple plastic bottle, the kind you see everywhere, actually help solve the world's water crisis? It sounds kind of crazy, right? But believe it or not, the answer might just be a big yes, all thanks to some really clever chemistry.
Okay, so to really get why this is such a big deal, we need to understand the scale of what we're up against. We're talking about two massive, tangled-up problems here. So on one side, you've got this ever-growing mountain of plastic junk that's choking our oceans and filling up our land. And on the other, you have billions of people who don't have enough clean, fresh water. Now, you might think these are totally separate issues, but as we're about to see, one super smart idea actually connects them.
And just to give you an idea of the plastic problem, a recent survey showed that greenhouse gas emissions just from making plastic were set to jump by 31% in just 15 years. Yeah, it's a huge source of pollution from the moment it's made to the moment it's thrown away.
All right, so faced with this pretty grim picture, researchers started to think, outside the box. They stopped looking at plastic as just garbage and started wondering, what if it's actually a resource? And this all fits into a bigger idea called the circular economy. You've probably heard of it. The basic idea is to get rid of that old take, make, and throw away model. Instead, we create this loop where everything gets reused, recycled, or repurposed. Nothing goes to waste because everything has value.
And that leads us to the big aha moment behind this whole thing. The really brilliant question. What if we could use one of our biggest problems to solve another one? What if we could take all this plastic pollution and use it to tackle water scarcity? This is where things get really interesting.
I know, it sounds a little like something out of a sci-fi movie, but turning a plastic bottle into a water purifier is actually, surprisingly straightforward. So let's get into how they actually make this thing they call a super sponge.
Think of it like a recipe, really. First, they grab a regular old PET plastic bottle. Yeah, the same kind you'd get a drink in, and they just shred it up. Next, they use a chemical process to turn those plastic bits into something called carbon foam. It's this black, kind of spongy material. And then, for the final touch, they add this special coating of nanoparticles that are just amazing at soaking up sunlight and turning it into heat. You can see it right here in this diagram. You start with the plastic, you mix in some pretty common salts and chemicals, you add some heat, and boom! Out comes this incredible new material. It's really a perfect example of what we call upcycling.
So what you end up with is this high-tech super sponge, and its job is actually pretty simple, but it's super powerful. You just float it on top of salt water, it soaks up the sun's rays, gets really, really hot, and that heat makes the clean water evaporate, leaving all the salt and gunk behind. Then you just collect that water vapor, and you've got pure, clean water.
Okay, so that's the idea. It sounds great in theory, but the real question is, does it actually work? And how well does it work? Well, this is where we get into the data. And honestly, it's pretty mind-blowing.
All right, first up, heat. Remember that special nanoparticle coating we talked about? Take a look at these thermal images. On the top, that's just the basic carbon foam. Under some simulated sunlight, it gets up to 68 degrees Celsius. Not bad. But look at the new material on the bottom. It rockets up to 74.4 degrees. That extra heat makes a huge difference for making water evaporate faster.
Okay, next up is a big word, hydrophilicity.
Sounds complicated, but all it means is how much a material loves water. For this sponge to work really well, it needs to be able to suck water up to that hot surface super fast to replace the water that's turning into steam.
And you have got to see this. When a drop of water hits the surface of this new sponge, it's just gone. Sucked up almost instantly. We're talking less than 1/10 of a second. This thing is what they call super hydrophilic, which means there's always a steady supply of water right where it needs to be to get evaporated. All right, now for the main event, the money shot. This chart shows the evaporation rate, basically how much fresh water it can actually make. So a standard desalination membrane, it barely makes it to 0.5 kilogram per hour. The basic carbon foam made from plastic is way better, at 1.6. But our new material, it hits a whopping 2.4 kilograms per square meter per hour. That is a massive, massive improvement. And just to put that number into perspective, let's see how it stacks up against some other really advanced materials that scientists are working on for the same thing. You can see a lot of them are kind of hanging around the 1 or 1.5 mark. So at 2.4, this thing isn't just a little bit better, it is an absolute top performer in the field of solar desalination.
So let's zoom back out for a second. What does all this data really mean? Well, it means we're looking at a real, powerful example of one of these circular solutions in action.
You know, I think the researchers who did this work said it best themselves. Their goal was to, quote, mitigate the water and plastic crises, thereby enabling the circular economy. This isn't just about making a cool new gadget. It's about totally rethinking how we look at waste and resources.
And that kind of leaves us with this really inspiring final thought, doesn't it? If an old, discarded plastic bottle can be turned into a device that literally creates fresh water out of the sea using nothing but sunlight, what other things that we call waste are just sitting there waiting to become the key to solving our next big challenge? Something to think about. Thanks for tuning in.